Hi everybody, welcome back to Calculus. Today we are going to be analyzing the first derivative algebraically. We will refer to a couple of the pages in your notes packet starting on page 109. One of the problems we'll do from there are printed in your notes packets, and then the other problems are going to come from Delta Math. It's just that the ones in your packet and the ones on Delta Math didn't align very well. So I picked the problems that align more with your assignment rather than the ones from the packet. I think it would just make it easier on you to do that. So it's kind of annoying if you're writing down notes, but you might just want to mark, you can mark stuff out or grab your own sheet of paper. But here's where we'll start. Okay, so if you look at page 109 in your notes packet, you'll see this explanation. It's worth giving it a minute to skim over, or at least read in your own time. It just discusses how to tell if just the function, not the derivative, if just the function is increasing when you're looking at the function. So this is what we talked about the other day when we were doing our pre-cal review. And some charts and a better look at that. But then there's this, and I think it's worth going over. What's true about the slope of the tangent lines in the increasing curves? So just take a note in all of these, the function, these are all functions, the original function. Well, I should probably name, I'll name them different names. But the tangent line at this point, the slope of the tangent line, if I draw little tangent lines on each individual point, all of these slopes of each tangent line, they're all positive. So what's true about the slope of tangent lines or the derivatives whenever the original function curve is increasing? Well, those tangent lines are positive. And this is a review a little bit about what you did last class. And then if you look at decreasing curves or decreasing functions, again, these are pictures of the original functions, but we can think about the derivative by sketching in tangent lines at each point. So tangent line here, tangent line there, tangent line there. I'll just sketch in all these tangent lines. Tangent line, tangent line, tangent line. Well, what's true about the slopes of these little tangent lines? They are all the slopes are negative. So the function was decreasing, but the slopes of the tangent lines, in other words, the derivative, was negative. So in your notes packet, it gives you a table. If the derivative is positive, f is increasing. If the derivative is negative, f is decreasing. Now, that leads us to the chart we did last class. Let me move this out of the way. So this chart is something that I told you to keep. We're going to refer to it several times today, so I'm just putting it back on the screen. So in case you didn't write it down or you forgot it, you need it. So here it is. We're going to refer to it a lot today. All right, so the first thing we need to do algebraically is we're going to find increasing and decreasing intervals. So in your notes packet, there's directions on how to do this. The first thing that you're going to do, let me grab the highlighter, is you are going to locate the critical values. Oh, that is not a highlighter. This is a highlighter. You're going to locate the critical values. And you do that by set f prime equal to 0 and solve for x. So to find the critical values, set f prime equal to 0 and solve for x. So then you're going to make a sign chart placing all the critical values on the x-axis. Okay, so let's just do the first step first. We're going to find the critical values. So I'm going to find, that means set f prime equal to 0. So f prime of x. So first of all, I need f prime. I'll take the derivative. Derivative of 6x squared is 12x. Minus derivative of x cubed is 3x squared. I'm going to set f prime equal to 0 and solve for x. That will help me find my critical values. So let's see. Set f prime equal to 0. Right, and then I'm going to solve for x. So looks like I'm going to try to factor. There's a greatest common factor of 3x that I can factor out. That would leave me with 4 minus x. And then I can set each factor equal to 0. So that gives me two numbers, x equals 0 and x equals 4. So those are my critical numbers. All right, so all of this right here is how we locate critical numbers. Algebraically. Find the derivative, set it equal to 0, and solve. Because critical values or critical numbers are where the derivative equals 0 or it doesn't exist. All right, then I'm going to make a sign chart, placing all the critical values on the x-axis and creating intervals. So here's what that will look like. So I'm going to make a chart, which is just a number line. Hold on, I want a different color here because I'm on a different step. So this is a number line with x values for the derivative function. And I'm going to put my critical numbers on there, 0 and 4. So this creates intervals because this is a number line. So on the left side of the number line, we have negative infinity, then 0, then 4, and then infinity. So now I've created 1, 2, 3 intervals, an interval from negative infinity to 0, an interval from 0 to 4, and an interval from 4 to infinity. Okay? Creating intervals, done. Then I'm going to use a test number in the interval to determine the sign of f prime on that interval. So I'm going to use a test number in each one. So let's say between negative infinity to 0, a test number could be like let's do negative 5. And then a test number from 0 to 4, let's pick an easy number like 1. And then from 4 to infinity, let's pick another number like 10. I can pick any number in each interval. I usually just try to pick numbers that are easy to think about. Now I'm going to test these numbers into my derivative. And here's a pro tip. It's easier to test it into the factored form. So this is the derivative, this is the derivative, this is the factored form. It's easier on you to test it into the factored form of the derivative. So 3x times 4 minus x. Because if you substitute it into the factored form, then you can just think about positives and negatives multiplying together, because we just need to determine the sign of f prime on each interval. I don't need to know what it is. Okay, so these are my test numbers. All right, so now I'm going to figure out the sign of f prime in between negative infinity to 0 by testing the number negative 5 in for x, so in for each x right there. So let's see, if I substitute in negative 5 in the first factor, 3 times negative 5 would be a negative, and then negative 4 minus negative 5 would be positive. So a negative times a positive for this interval would be negative. So negative times positive equals negative for this first interval. Okay? I'm trying to erase those lines there. Is eraser. All right, so now we're going to test 1 in for each x value. All right, so if I put 1 in for the x right here, I'll have a positive number. And then 1 in for x right there, 4 minus 1 is also positive. And a positive times a positive is a positive. So the sign of f prime from 0 to 4 is positive. Okay? Now, let's test the third interval. We're going to use number 10, and I'm going to test 10 and for x. So 3 times 10 would be positive. 4 minus 10 is negative, and a positive times a negative would be negative. So we did our test numbers, and that allowed me to determine the sign of f prime on each interval. Okay, so what am I trying to see? I want to see the full page. Okay, so what am I trying to see here? I'm trying to see increasing and decreasing interval. And so I know that my function is increasing whenever f prime is positive. So I have a sign chart down here that shows me, can't find my arrow here, that shows me that f prime is positive right here. So if f prime is positive from 0 to 4, then I can say that f is increasing on the interval from 0 to 4 because that's where f prime is positive. And then I also have to determine where f is decreasing. So if I go back to my chart, a function is decreasing when f prime is negative. So then I look at my sign chart for f prime, and I see that f prime is negative from negative infinity to 0 and also from 4 to infinity. So I can say that f is decreasing on the interval from negative infinity to 0 and also on the interval from 4 to infinity because that's where f prime is negative. So that's the idea. First, you need to find the critical numbers, put those critical numbers on a number line, make a sign chart to test the intervals, and then make your conclusions. So let's see how that will look in Delta Math. Find all intervals on which f of x is decreasing. So here I don't care about increasing. I only want to know where f is decreasing. So that means I'm going to be looking at the places to figure out where f prime is negative. Okay, so first of all, I need to find f prime. So let's find the derivative. Derivative of 2x to the fourth is 8x cubed plus derivative of 16x cubed is 48x squared. And the derivative of 30 is 0. All right, so I found f prime. I'm going to set it equal to 0. I'm going to factor it. Looks like I can factor out an 8x squared from both terms. X plus 6, yeah. And then if I set each factor equal to 0, I'll get that x to be 0 and x to be negative 6. So these are my critical numbers. So I'm going to make a number line and divide it into intervals based on my critical numbers. So this is a number line. Let's see, let's do 0. Oh, no, negative 6 comes before 0. Let's try that again. Negative 6, then 0. So now I've created 3 intervals, an interval from negative infinity to negative 6, an interval from negative 6 to 0, and then another interval from 0 to infinity. I'm going to be testing numbers in between here. So let's say like I'll test a 1. That seems to be an easy number to substitute in. A number between negative 6 and 0. Let's do like negative 2. and then a number between negative infinity and negative 6. Let's try negative 10. All right, so I'm going to test those numbers into my derivative. And we're going to use the factored form of the derivative, 8x squared times x plus 6, just to make everything easier to think about. Okay, so let's try negative 10. If I substitute a negative 10 for the first factor, 8 times negative 10 squared is a positive, times negative 10 plus 6 is a negative, and a positive times a negative is a negative number, which means this interval on the derivative is negative. Now let's try testing negative 2. If I substitute a negative 2 right here, 8 times negative 2 squared is positive. Substitute in negative 2 here. Negative 2 plus 6 is positive, and a positive times a positive is positive. So this interval is positive. And then erase, there we go. Now let's try testing 1. I substitute in 1 right here. 8 times 1 squared is positive. And 1 here, 1 plus 6 is positive. And a positive times a positive gives me a positive number. So I have my sign chart. I know that f prime is negative from negative infinity to negative 6, and then positive everywhere else. So now I just have to answer the question. The question is, when is f of x decreasing? Well, f of x is decreasing whenever f prime is negative. So I need to look to see where that happens. Well, that happens on this interval right here. So I will say that f of x is decreasing, not decreasing, decreasing on the interval from negative infinity to negative 6 because f prime is negative. So then sometimes they'll give you, so in this last example, example 2, you were given f and you had to determine where is f decreasing. Sometimes they'll give you an equation for f prime, but then they ask you when is f decreasing. So just be careful, read each question carefully, and always refer back to your chart because it helps you stay grounded. So, okay, so this time I'm looking for where is f decreasing. So where is f decreasing, okay? F is decreasing when f prime is negative. Oh, well, here they already gave me the formula for f prime, so I just have to figure out where f prime is going to be negative. Well, let's see. I need to find where it's negative. So there's the formula for f prime. Set it equal to 0. X squared plus, not x squared, x cubed plus 15x squared minus 54x. Now, really the only difference between this one and the one we just did is that here I had to find f prime on example 2. Example 3, they already gave me f prime. All the remaining steps will be similar. So I already factored it. I got my critical numbers to be 0, negative, 9, and 6. So now I'm going to make a number line, create my intervals, negative 9, 0, and 6. And this is f prime. Let's see, a number I'm going to test on each one. Let's test negative 10, negative 1 between negative 9 and 0. Test a number between 0 and 6. Let's test 1, and then let's test 10 from 6 to infinity. All right, and f prime is equal to, let's use the factored form right here. Okay, x times x plus 9 times x minus 6. Okay, so if I take negative 10 and substitute it in for the first x, you get a negative number. If you substitute a negative 10 right there, I get a positive, nope, not positive, that's negative. Another negative number. Negative times negative. And then substitute in negative 10 for negative 6, or x minus 6, and we get another negative number. So a negative times a negative times a negative makes this overall interval negative. Okay, now let's try testing out negative 1. If I put negative 1 in this first part for x, I get a negative. If you put negative 1 here, you get a positive number. If you put negative 1 here, you get a negative number. So a negative times a positive times a negative is positive for this interval. And then a number between 0 and 6, if we try 1, so I put 1 here, that's positive. 1 plus 9 is positive, and 1 minus 6 is negative. A positive times a negative is negative overall. And then let's try the right color here, 10. So I put 10 here, that's positive. 10 plus 9 is positive. 10 minus 6 is positive. Positive times positive is also positive. So now I want to use my sign chart and determine where f prime is positive. Or sorry, where is f decreasing? F is decreasing when f prime is negative. So it looks like here from negative infinity to negative 9, and then from 0 to 6. So I can say that f is decreasing from negative infinity to negative 9, and also from 0 to 6. So then there's something called the first derivative test. The first derivative test is what helps us find relative minimums and relative maximums. So whenever we're looking for relative mins and relative max, we're looking for a change. If f prime changes from negative to positive, then we've got a relative minimum. So here's a picture of a relative minimum. F prime does need to change from negative to positive to have a relative minimum. And also we have that listed into our chart. If I want a relative minimum, I need to change from negative to positive. For a relative maximum, I need to change from a positive. F prime needs to change going from positive to negative. So we'll use that information here. If you don't see a change, then there will not be a relative minimum or maximum. So let's look at example 4. This is one like you'll have on Delta Math. Find x coordinates of all relative minima of f of x. So I'm looking for relative minima, or that's just plural for relative minimum. So f will have relative minimum whenever f prime changes from positive to negative. So I'm going to do the same thing. I'm going to make a sign chart, and then I'm going to look for changes. So I'm going to pause, do that work, and then talk about that change. Okay, so I saw that I found f prime, set it equal to 0, factored, set each factor equal to 0. Now I've got my critical numbers. Okay, so then I've loaded my critical numbers on a number line. I tested some test values in the intervals into my derivative, and I got that my sign chart for f prime is positive, positive, negative. Now to find a relative minimum, remember I need to look for where f prime is going to change from negative to positive. And you have to read the number line from left to right because that's the way that numbers work. They work, meaning they go from the lower number to the smaller. So I'm looking for where I see f prime changing from negative first and then positive. Well, right now it's positive, positive, and then there's a change to a negative. That's not negative changing to a positive, that's positive changing to a negative. So this is not, doesn't look like there's anywhere where I'm seeing a positive and then a negative. So since I don't see any change from a positive to a negative, I can say that this example would have no relative minima. Because f prime does not change from negative to positive. Now, when you go to enter this in Delta Math, you'll just leave that answer box blank and you'll just click submit. And it didn't say to do that, but that's what you'll do on this one. All right, so here's another one. Find all the relative. Now here we're asked to find relative maxima. So let's find relative max. To find the relative max, I need to look for where the derivative changes from positive to negative. So find the derivative. So it would be 4x cubed minus, let's see, 8 times 3 is 24x squared. Now I'm going to pause it and find my critical numbers. All right, so I found my derivative, set it equal to 0, factored, set each factor equal to 0, found that my two critical numbers are x equals 0 and x equals 6. Now I have my critical numbers on the number line. I'm ready to analyze. So let's do the sign chart. Let me just make this thickness a little smaller. Okay. So if I substitute a -1 in for x squared, that's going to give me a positive. -1 minus 6 is negative. So net positive times negative, this interval of f prime is negative. Now let's substitute in 1. So if I set 4 times 1 squared is positive. 4 times 1 squared is positive. 1 minus 6 is negative. Positive times negative is negative. I feel like I need to check this one. I'll check that one again. And then the last one, there we go, 10. 4 times 10 squared is positive. 10 minus 6 is positive. Positive times positive is positive. Let me just double check this other one more time. All right, so -1 squared is positive. 4 times 1 would be positive. -1 minus 6 would be -7, which is negative, and a positive times a negative is a negative. So I need to look for where there's a change from a positive to a negative. Looks like there is not a change from positive to negative. I've got to change from negative to positive, but not positive to negative. So I'm just going to double check my work. Yeah, I just doubted myself for just a second because we have a problem with no relative max again because we are not seeing a change from positive to negative. So we'll say that there is no relative max. All right, moving on. One thing you'll be asked for is relative max and relative min. You can find those by analyzing the signs. The other thing you'll be asked for is how to find the absolute maximum and minimum. So the absolute maximum or min could happen on the end points of a curve, or it could happen that a relative max or min could also be an absolute max or min. So like if I were to have a section of a graph that looked like this, then the highest point of the graph is right there. So that would be an absolute max and a relative max. So sometimes you'll be asked to find the absolute maximums and minimums. So what you'll need to do the same thing you did before, look for relative maxes and mins, but then you also need to check and see if it's going to happen at an endpoint. So let's look at an example where that could happen. So we have example 6, given the function f of x equals x to the 4th minus 4x cubed minus x squared plus 8, determine the absolute max or determine the absolute minimum value. So what you're going to do is, number one, you're going to find all relative minimums first. So I'm going to find all relative mins using the procedure that we did before. And to find a relative minimum, I need to look for where the derivative changes from negative to positive using my chart. So I'm going to pause the video, do that right now, and then we'll come back and talk about it. Okay, so I have found my derivative, factored, found the critical numbers, set the critical numbers on a number line. Let me just double check that I'm recording. Yes, okay. And now I need to find all of relative minimums. All right, so relative mins happen when f prime changes from negative to positive. So there'll be a relative min at x equals negative 1 and at x equals 4 because we see a change from negative to positive. So we know that there are relative mins at x equals negative 1 and x equals 4. Okay, now I'm going to look at the question. The question says, determine the absolute minimum, not just the relative min, the absolute min on the closed interval from negative 2 to 2. So let me add those numbers here. Negative 2 to 2. So on this interval of the graph, they want to know what's the absolute minimum. Oh, well, 4 is not even included in there, so don't have to worry about checking 4. But I do have to check. So my absolute, there's 3 possibilities for where my absolute minimum could be. So my absolute minimum could be it could be at the relative minimum. It could be at x equals negative 1. But it could also be one of the endpoints, or at x equals negative 2, or at x equals positive 2. So I've got 3 candidates for where the absolute minimum point could be. So to figure out what that is, I need to evaluate f of negative 1, f of negative 2, and f of 2 to figure out which one is the smallest number. And notice I'm not evaluating f prime, I'm evaluating the original function. So evaluate original function. And my original function, once again, is right here. So I'm going to pause, find those values. Okay, so let's view the whole page. All right, so I have evaluated, so I took the original function, f of x equals x to the 4th minus 4x cubed minus 8x squared plus 8, and I substituted in 1 for x, and I got negative 3. Then I took the same function, substituted in 2 for x, got 24. Then I took this same function again, substituted in 2 for x again, positive 2 this time, got negative 4. I need to find the absolute minimum. Since it's the absolute minimum, that means that's the absolute lowest number. So the absolute minimum is right here. And then here's a note that you're going to see on page 131. What the absolute minimum is the y value. Where it's located is the x value. So here's how I would say this out loud. I would say the absolute minimum is negative 40, but that occurs at x equals 2. And that's how you would answer the question. Now, if this question instead were to not ask for the absolute minimum, but the absolute maximum, the procedure would be the same, except instead of finding the absolute lowest number, you would find the absolute highest number.